I keep screwing up and I keep take after take because I can talk all day long if there's no camera. When there's a camera, you get a bit tongue-tied, you know what I mean? Welcome to the video, the separate video I've done on the valve radio from the 1957 Plymouth. Now, I've rewired the Plymouth in I think 4 videos or something like that. Didn't spend any time on the radio because I want to do it separately. These are really quite interesting kit. Of course, I've got this little guy here, which is in appalling shape. Now, we're not going to restore it, we just want to see if it works. I've ordered another one ex-USA, so that should be here soon. And I just want to get one working. If I can make sort of 1 out of 2, yeah, I'll do it. This one, for example, if it works, is all good, but the face is absolutely cactus, so I need to look at that. So I just want to get it working, as I don't want a modern stereo in this car. So I want a valve radio, I want the original kit in the car, I want it to look and operate like normal. Because I think there's sort of an element of cool to it. Of course, we look at these things now, valve appliances are becoming really popular, even on eBay with preamps and stuff like this. You can get preamp kits with 2 valves, or tubes if you prefer, for as little as 15 bucks. And of course people use them for guitars and turntables and all sorts of stuff. They're making a real comeback now. Another thing that are making a comeback, of course, when you've got a row of these in the form of a Nixie tube, which isn't really the same thing, but they look a bit like that. And of course people have Nixie tube clocks, that sort of stuff. So I just want to do a separate video on this because I think it's interesting, and I certainly hope you do too. So we often refer to modern times as being hustle bustle, a lot of technology moving ultra fast and all that sort of stuff. And of course, back in the 1950s and so forth, things were a lot more relaxed and a lot slower. But in fact, there was an awful lot happening in terms of electronic technology. And in fact, Chrysler and Philco, I believe it was, I think it was 1955, it might have been 56, developed the first all-transistorized car radio. Now this is a bit odd. This is 1957. Of course, it's a bit of a hybrid. Can we see that there? That's a power transistor, and it's also got these tubes in here. Now, they're IF and RF amplifiers. This thing's a power amplifier, so that controls what comes out to the speakers. This is more about the signal coming in, the radio signal coming in. Now, valves are interesting. I call them valves, being Australian because that's how we refer to them. Of course, Americans call them tubes. Now, let me have a look at the number. It is one. I need a magnifying glass because I'm half blind, but anyway. 12AF7. So if I write that down here, 12AF7, AE7, AE7 I should say. Of course, that refers to the voltage coming in. This refers to what the valve does, which in this case I think is a triode, and that's the amount of elements it has inside, which of course includes the heating element. Now, these work in a really, really unique way, and I'm going to do a little demonstration with a picture tube on a television set in a moment to sort of explain it a bit better, because the picture tube sort of gives you a visual representation of what's going on inside. Now, we have a bunch of pins, we have a heating element in there, and when we look at a heating element on a valve, we just think of a little coil, like that, with a pellet above it. And you'll notice when you turn these things on, there'll be a faint orange glow down the bottom. That, of course, is the heater, and the pellet's a cathode. And of course, when you heat that cathode, it produces a cloud of electrons. Now, these things take a little while to heat up, which is why these impromptu scenes in movies like Christine, where the radio comes on with no warning and sings a 50s song with some sort of hidden warning for its for the naughty boys about to smash it, that sort of thing. That's not really possible with a valve. A transistor you can do that, a valve you can't. Right? They need to heat up in order to get those electrons flowing. And of course, what happens is electrons can fly through a vacuum really, really quickly, and they go through a series of grids where they're attracted to a charged plate. And of course, that gives biasing as necessary. Now, transistors are different in terms of they need to, they rely on positively and negatively doped silicon that sort of form a gate that allow power through and all that sort of stuff. Now, transistors are such that the 3 fellas responsible for bringing the transistor to fruition in the 50s were, of course, awarded the Nobel Peace Prize in 1956. And, of course, transistors have just taken over since then in integrated circuits, that sort of thing. In fact, to the point where a computer die can have millions and millions of them on a little die the size of your pinky fingernail. If we look at, I might just move the old radio and my little, I haven't got a whiteboard out here, and I just want to see how far I can go up, which is up here somewhere, and I can get down to there. Right, so if I draw a transistor, which is like this, and this is NPN, which is not pointing in, hence that. And on a transistor we have sorry, a base, collector and emitter. So basically this can form two functions. It can act as an electronic switch. So 0.6 volts, and this will sound wrong, is hard on. So any voltage coming down through here can be passed out. And zero volt means that this is closed, so nothing can get through. Now, these can be switched on and off many times per second and form incredible feats. For example, it's used in television sets to scan the electron beam to form the picture. And I'll talk a little bit about TV sets. I've got an old black and white one here. I just want to pull the cover off and show you a couple of things in it. Now, when you first turn one of those old sets on, you'll hear a very high-pitched noise. That's probably around about 14 kilohertz, and that's one of these blokes turning on and off really quickly. Now, they can also act as an amplifier. And the way they do that, I've just got to remember this from my old electronics days, is we have, I'm coming from the wrong direction actually, and then we have an output there. And that goes to a speaker. And of course the input, I've got to move to the other side of the camera. The input is where our microphone is. This is just dumbed down, so it's positive, that's negative, and sometimes there's a little filtering capacitor in here, and of course here's our little microphone. Now, the way this works, I've got an old speaker here, just a moment, I'll just grab it. Okay, so if we look at this old speaker, and this is absolutely desecrated. This is an old Philco speaker. You can see it's got a voice coil in it, which is stuck. There's the voice coil there. And of course what that is essentially a permanent magnet, which is there. And a microphone is much more sensitive and much smaller than this, obviously, but they work on a similar principle. And then you have your voice coil, which is the paper bit missing here with this coil attached to it. And what happens is that you get the voice coil moving over that permanent magnet very quickly. Of course you speak in here and it vibrates, moves the coil over the permanent magnet extremely quickly. Magnetic field breaks down in the coil, inducing a voltage. Now, what that does is it powers the transistor. It turns the gate on, or the base on and off, and in all different increments between 0 and 0.6 volts in this case, and breaks off proportional chunks of voltage, which is then replicated precisely the same out of the speaker. Hang on, I've got to draw a sine wave. Yeah. Much bigger. So, looking at this, you would think that the output would be on this end, but that's conventional current flow. We're talking electron current flow, which is negative through to positive. Conventional is positive to negative, how we all think of it, but that's what electron current flow goes the other way. So they're very versatile bits of kit, extremely versatile. So we'll just pop that back off. Now, if you ever do this sort of thing, these things hold a tremendous amount of current inside, not just from large capacitors, but in the picture tube itself. And I'll explain that when I show it to you. Where's the other screws in there? The actual picture tube itself acts like a capacitor because it has a lot of voltage from a flyback transformer that goes into it, and of course it's coated on the inside with a conductive coating and on the outside with an aquadag. Hopefully this just pops off. Maybe I'll pull this off. Ooh, pull this off too. And so mucking around with tellies is something you shouldn't do. Unless you know what you're doing. Right. Okay. This hasn't been operated for years and years, so it's probably actually alright to touch, but still, I am not going to do it. Oh, that's very good to see. Look at that. We can see everything. So let me just pop this over. Oh, this is good. I like this. Right, so this operates like a valve as well. We've got the neck board here, and that controls an electron gun in there. And the electron gun is just, like I said before, a little pellet, if you like, with a heater under it. And of course your cloud of electrons come off and they hang around in here. Now, from there they go to a focusing grid, and that converts them from a cloud into a very fine line. Of course, then under here we go through an accelerating grid, which shoots them out. And this little guy here is called a flyback transformer. This coating on the back of this is the aquadag, and the inside of the screen is a conductive coating, and of course that is your final anode. This is a little black and white set, so it's probably pushing 15,000 volts through there. If you do take these off, you discharge them, because that acts as a capacitor, with the aquadag on one side, the conductive coating on the other, and the glass acts as the dielectric. So you can have a lot of charge stored in here. The thing you discharge them with looks like a kettle probe, or you can check the voltage with looks like a kettle probe. Now what happens with these electrons is they fly out here, they hit the back of the screen, which is coated in phosphor, and you see a tiny little dot in the center. Now, the job of these things here, these are the deflection coils, and so what happens with those is they send the beam up to here, and it goes along, turns off, back, on, off, all the way down to the bottom, turns off, comes up, on, off, on, off, on, off. So it's presenting you with a bunch of still pictures, which persistence of vision makes it look like a moving picture. Now in a colour TV, there are 3 electron guns, of blue, what is it? Blue, green and red or something, I think. Now what they do is they go through a masking, what's it called? A shadow mask, I think, just at the phosphor level at the back of the screen, and of course that masks out the colours as they come through to give you an accurate representation. Of course, a mix of all those colours give you every colour in the spectrum. Now, sometimes with the old TV sets, these wear, just the same as hi-fi tubes. Oh, I stood on the thing. Just the same as these tubes, these cathodes wear. That little pellet gets a bit dirty, and of course then it can distort colour and that sort of thing. Now, for example, what's a good example? Okay, so if you're watching your colour TV and the picture's a bit washed out, maybe a bit creamy, the whites aren't white anymore, that'll be the blue electron gun starting to fail. And then of course you can overdrive them. Now that will burn off any crap that's on the cathode, but in doing that it will be a temporary measure, so it'll fix it for sort of a year or so. This is a black and white, so there's only one gun at the back. Now, what did I say that the final anode shot the things forward? I think I did, didn't I? So that's electrons at their best, and they're quite similar if you see. That is basically just a valve, or a very elaborate valve. Of course, the electrons here are designed to go onto a plate through a series of grids. These ones are focused through grids designed to hit the back of phosphor and light up. So it's all very similar technology, and they do wear, and that's of course what goes on with these things, and it might be the reason why I've got such a weak signal on our little Plymouth radio. Now this set's out of a cupboard at Mother's house. I'm just going to pop it on. Okay, now we don't... Oh, there we go. Hang on, let me just undo this. We can see the little heater at work. That orange glow. You can probably see it on video, this sort of scanning thing. It doesn't show in normal light. Of course, analog transmissions are finished now. But now that that's been switched on, we don't touch a thing. Now in the old TV sets, they had what's called a live chassis. So they were it was all live with mains voltage down there. So very dangerous kit. Very, very dangerous kit. Can you see that? I don't know if you can see it. I might turn the light off. There we go. That's easier to see the heater. Interesting, isn't it? So a wonderful friend, Michael Raymaker's gave me a bunch of wiring bits and pieces, and of course I've got these inline fuses here. I've plonked a 10 amp one in here. The radio is meant to have, yep, that's it. The radio is meant to have a 7.5 amp fuse. I'm just going to, it doesn't fit on the old fashioned carrier. I'm going to twist that around there. And I reckon we stick some juice through. Now, the other thing I've got is this rather old Mitsubishi speaker from about 1975. It's a new old stocky. And I just found this inside. And I don't have the correct Plymouth one, which is a great big oval thing. But this one will let me hear one or two things if they emit from our radio. So I can connect that up with a bunch of alligator clips. Haven't got any action. Nothing. Right, so let's have a good bit of a look around. Well, that would have something to do with it. We're not getting voltage going through there, so we've got no power. Right. Well, the unit's powered. It's getting 12 volts in there. Getting some static, but we're not getting anything else. Are those valves lit up? Yep, we've got some valves lit up. Yep, they're all lighting up. We haven't got an antenna in. I've just got a screwdriver hanging out of that antenna jack. But valves do take a while to heat up before they start working. I don't know if you can see down there. There's one you can probably see where it's got a little bit of a light at the bottom. That's the heater, that's the cathode heater. So I'm just going to let it sit there for a bit. See if I can get any joy out of it. I don't have an old antenna though, it needs a ground plane. But so far I'm not getting anything, so it's worth sort of waiting for it though, I think. Right, well I just had... Oh, look at that. It is very quiet, but we are getting some signals, which is really cool. Is that the Miami Vice soundtrack? No. But anyhow, look, that's positive. It hasn't got a proper antenna. But the other thing is, these valves might be old and crummy, so a new set of tubes, or valves if you like, might actually help it. I'd have thought that looking at large capacitors like that thing, that's one of those old wax ones. So a lot of the time when people overhaul electronic equipment, old electronic equipment, they actually recap them. But I can't see a light in there. I'll take the cover off and see if I can get a light going, but that's not bad. So we've got the second one hooked up now, and we're getting power into it, but I'm not getting any. I'm not getting any there. I wonder if that pot's us. Not getting a sausage, but I can't see any of the valves lighting up. But it is, yep, it's all connected, and we're getting power in. I've already found the problem here, or one of the problems. If I that's the power into the switch. We've got line voltage there. One of those wires looks a bit black, so there could be a problem with it. So I've got, yep, voltage going in there, but nothing coming out. So there's a problem with that switch for a start. So I'm not going to bother investigating this anymore. It'd be kind of cool to restore it, but I think we'll concentrate on our eBay radio. See, this is what I love about the 50s. They're sort of die-cast steel type knobs. They're really, really good. I'm just going to take this fascia off. This is the one that I bought on eBay, the one I'm going to use in the car. I'm not going to use the original one. The original one's pretty messed up, and we're not even getting signal out of the switch, which is no big deal. It's like to be expected. This one here is incredibly easy to overhaul. It's actually got a different front panel too. There are some subtle differences with it. That whole front panel's different. I just hope it fits in a bloody car. If it doesn't, I'll figure it out. I'll make it fit. But what I want to do is I want to figure out the light, because I want to oh I see I want to, it's got no light there. Oh yes it has. Oh, it's got two. So I'm going to power these lights up independently so they come on with the headlights, not the radio. And it's missing one there. I'll repaint that needle. It's also got this they seem to be good at doing stuff like this, don't they? It's got that paper thing there. It just looks, I'm just hoping that fascia fits in the car. I think it does. It looks like it does. Like the curving and the screw holes, everything looks about the same. I'm going to take to that with a buff. I'm not expecting miracles, but if I can get it a little bit better than that, it'll do for now, until I'm ready to do something more with it. Of course, the Mopa, original 854. As I said, there was a whole bunch of model numbers pertinent to this vehicle. So this one's an 848, I think. So slightly different. I prefer this any day of the week, not just because it works, but because it looks a lot simpler. Now I reckon this would be a doddle to overhaul. It's got a couple of big fat, waxy looking caps in there. You'd change those, put a new set of valves in, give it a good clean up. Even some of those disc capacitors, you'd probably change those out as well. Put some new wiring in it. That is, I don't know what that is. I'd need to sort of brush up on my electronics. I'm electronics trained, but not well practiced. So I need to look at this sort of stuff. Their little bayonet illumination globes there, which we can put some new ones of those in. But I just need to see where they're wired to. And already, I think I can see it. I think it's that little wire down there. I don't know if you can see in here. It's pretty ridiculous. I think it's that one there. So I can just take that off and run another signal cable out of there, because I do want it to come on with the lights and the radio off, which is probably futile. But I know exactly what I want out of it. And this is all looking really good. I'm happy with that. It cost me like $60 American, I think, and about another $60 to get it out. It was like $150 or $160 to get here. But I reckon it's worth it. I'm really happy with it. It's cool. Right, so I've taken this off. I can make new reflector material. I might be able to get that back in. I don't know. I'll have a look at that. What's odd is that the dial indicator, or the dial indicator, the dial lights are wired in series, which means they're two 6-volt globes. Why on earth would they do that? It might just it's just sort of areas like in there. If I can get rid of just some of that sort of tarnishing. I think this reconditioned one's about 260 American. So it might be such that, I mean, once the interior is done and the steering wheel's done, this is probably going to scream. So, you know, it might be necessary to sort of look at a better alternative. I just want to get this car in one piece and driving. And you know what, that'll be alright. It's not brilliant, but it will be okay for now. The heater control part down beneath is much worse. And now I've turned the camera on. I've got a blowfly flying around. I've fixed this up here. I only had one good globe. That one's shot there, so I've had to go and buy a pack, and it's much better buying just packs of these sorts of things because you get them quite cheaply. I think this was $16 or something for 10. And so I'm just going to bang a couple of new globes in, and I'll test it out with a battery. So yeah, it was probably unorthodox what I did in terms of wanting this thing to work with the headlights rather than the radio, but it doesn't matter that much. I've also painted the tuning needle, the little indicator thing. You just use this stuff, and of course you buy it from any of the restoration houses. I think it's from the US, and there's only a tiny bit. There's a little ball bearing in there that keeps it nice and stirred up. You'll do 50 speedos with that. You do a lot of gauges with it. So I've just used a little bit on here just to match the rest of the car. And of course, once we put that in behind a nice lit up thing, it'll look quite good. So that's just a small brush or a cotton tip. I used a cotton tip, which isn't that great really, because a cotton tip is going to absorb it and you'll use more of it. Interestingly, this has a transistor there too, as well as tubes. So this is going to go that way. So this just sort of clamps over in there. Sort of like that, somehow. And then this side does the same thing. This way. I haven't done this well. I might have fudged this up actually. I'm just bang it over a battery, and what that'll do is it'll make sure that that's earthing. Whoa, earthing properly. Let's see. Whoa, keep kicking the thing and see if this works. There we go. So I've got light, which is a good thing. So I'm just going to use a little bit of kitchen cleaner on this old t-shirt. Spray it on and see if I can clean these buttons up. There's a chance that they've got years and years of muck on them, which shouldn't be too hard to lift, although there is some residue there which is proving to be something of a challenge. But if it can be original, I don't care if it's tarnished in terms of the chrome, because it's original. Now, I don't care with a car if it hasn't got the original motor or it's not numbers matching. I couldn't care less about that stuff because I don't have anything that's really collectible, but I do like them to look period correct, and that's the reason I'm doing this valve amplifier, because I don't want a modern stereo. I think that destroys a car, an old car, which is the reason why some designers put them in glove boxes, and they actually state, I mean, Chip Feast himself stated that the first thing that dates a car is its stereo, and he's right. So I'm just going to do it this way, take a bit of that muck off, and now this design was around the 70s, where you pull the button out, pick your station, and then put it in, and it locks onto that station. It's an old design. Anyway, that'll do. So that is it for part one of the radio video. It's not a full restoration, just a sort of a recommission on what we've got. I can't use this old Philco speaker, it's pretty much had it. So in the next video, we'll put a new set of tubes in, valves in, it's got a mark on the glass, and stick it in the car. I'm going to put it in now anyway to get it off the bench, but I'll put it in the car, switch it on, plug an antenna up to it, make it work, and get another speaker for it as well. So, drive safely, enjoy classic, and I'll see you later. Yes, I will. Much later. Bye.